Okay, we have a number of circles, so 1, 2, 3, and we have to figure out the number of intersections based on the amount of circles. So for the first one, we have 0 intersections. When we have 2, we have 1 and 2. And when we have 3, we have 1, 2, 3, 4. 4 intersections. And when you notice, you have 2 and 2 as your first differences. That means when we have 4 circles, we have 6, because 6 minus 4 is 2. And since we have the same first differences, this relation is therefore linear. And since it's linear, we actually have to figure out or come up with an equation that relates this with this. So let's let C equal to number of circles, and let's let I equal to number of intersections. So intersections. Okay, so we know that if we add a circle, we go up by 2 in the amount of intersections. So we know that I has to equal to C. We know it has to look like something like this. Okay, so when we have one circle, when we plug in 1 here, we get 2 intersections. But here it says we have 0. So that means we have to do minus 2 to make it into 0 for the first one. And so this equation works for our first row. Okay, so what about our second, when we have 2 circles? When we plug in C equals 2, we get 2 times 2, which is 4, minus 2, which equals 2. So it works for this one as well. And then 3, we get 3 times 2, which is 6, minus 2 is 4. So it works for all 3 cases. Okay, so now based on this, we have to extrapolate the relation to predict the outcome for the 7th step. So when C equals 7, when there are 7 circles. Okay, so we do I equals to 2 bracket 7 minus 2. I equals to 2 times 7 is 14 minus 2, which is 12. So therefore, when we have 7 circles, so when there are 7 circles, note that I equals the number of intersections, so there will be 12 intersections. So there are 12 intersections.